explained the introductory parts of Kirchhoff's laws, where I treated or where I discussed two statements, current statement and voltage statement, or voltage law, so to say. So today we are going to apply the two statements in solving electronic circuit of this kind. So here we have a clear schematic representation of an electric circuit, okay? We're going to take it in a clockwise direction, right? This A, B, C, D, E, F, and then back to A. That's the loop we're going to consider. So without wasting time, let's delve into it. So the loop we are considering here is A, B, C, D, E, F, and then A, back to this A, right? So we take our direction clockwisely, all right? That's what we're going to do. So the first one here is the resistor offering resistance of 80 ohms. We have I current 2, resistor 2, all right? And we take it that way. This is in opposition to our direction, so it's going to be minus E2, minus E2. We move down again to this point. This electromotive force is in our direction, so we're going to take it as positive, and that is plus E1. Then we move again. There is a potential drop here, and then a resistance of 100 ohms opposing the direction here, so it's going to be negative. We have minus current 1 and then R1 all equal to 0. This is exactly what Kirchhoff's law is all about. Now, we are going to rearrange this. If we rearrange this, we have minus E2 plus E1, and then we have equal to current 1, R1, okay? And then this minus current 2, R2, all right? Quickly we substitute. For EMF 2, that is this, is 80, and then for EMF 1, that is 100 volts. We have 80 minus 80 volts plus 100 volts, all equal to resistance. From resistor 1 is 100 ohms, so we have 100 ohms, current 1 minus. Resistance from resistor 2 is 80 ohms, we have 80 ohms, current 2. Very simple. So that is it. For that simplification here, we give minus 80 plus 100 is going to be 20, all right, all equal to 100. We return these parameters, minus 80, we return this parameter. So this is the first equation, that is equation number 1. We have succeeded in generating equation number 1. We are going to generate another equation using the second loop. The second loop is going to be A, B, C, D, and back to A. So let's look at loop 2. This is loop 2. Probably this is loop 1, okay? Let's see. Loop 2 is going to be A, B, all right, C, or D, and back to A. This is loop 2, all right? While this is loop 1. So let's see what happens there. But before we delve into generating second equation using the second loop, I want to use this opportunity to ask you if you are finding value in this, if you are learning something, new concept in this, subscribe. Consider subscribing, right? Give us some thumbs up. Put on the bell button for constant notification. And then remember to share with your students, fellow colleagues, and then your friends, all right? All right, so let's go back to that. So we have this loop, A, B, we're taking this again. This is going to be I, current 2, resistance 2, right? If move this way, it's going to assume plus at this point, or we have E2, right? And then we move again. This is going to be plus again because it's in our direction. And we have I3, that is current 3, resistance 3, all equal to 0. Another way of representing the Kirchhoff's law. Alright, so we move on straight away and then substitute. For resistor 2 offering 80 resistance, we have 80 I2. Or before that, we need to rearrange the equation, and then we now substitute. We rearrange is going to be E2 is equal to, I2, right? R2, okay? And then we have, because of that, because there is this minus, so it's going to affect everything. We have plus I3 and then R3, okay? So at this point, we substitute immediately. We have E2 is 80 volts, then resistor 2 offering resistance 80 ohms. We have 80 ohms and current 2, and here we should, before substituting again, we should split this. We should explain further this. It means that E equal to E2 is equal to I2, that is current 2, resistor 2, right? Plus, we split this. This current 3 can be split. Look at the split here, meaning is the combination of current 1 and current 2 that gives current 3. So we need to split these 3 into bracket open current 1 plus current 2, bracket close, and then R3, right? That's what it should be. Alright, so further, we then have E2 is equal to, if we open this bracket, we're going to have a current 1, R3, and then because of I2 is going to appear, so we take 1, that is common, I2, that is current 2 brackets, R2 plus R3, okay? So that is it. We have succeeded in generating this equation, and the next thing we are going to do is to substitute wisely and then have another second equation, right? So if we substitute at this point, look at this point. We want to substitute at this point for E2, that is EMF2, it is 80 volts, all right? For resistance 3 is 50 ohms, right? So we have 50 ohms, that is I1, okay? And then we have another one, plus, this plus, bracket open, we have resistor 2 and the resistance 3, that is 2 is 80 ohms, 3 is 50 ohms, 80 plus 50 is giving 130 ohms. So what we need to do is just to remove the bracket, because we may not need the bracket this time around since we are combining the two resistances. So it's going to be 130 I2, right? Good. So we have that. We can now call this our second equation, equation number 2, right? That's equation number 2. It is now time for us to solve equation number 1 and equation number 2 simultaneously by applying simple elimination method. So we're going to bring them together and apply simple elimination method. The first one is 20 is equal to 100 current 1 minus 80 current 2. The second one, this is equation number 1. Let's take note. The second equation is 80 is equal to 50 current 1 plus then 130 current 2. Okay, this is equation number 2. Good. So we are applying simultaneous method of solving two equations by using elimination method. So what we need to do here is to find a way to normalize 50 with 100, okay? To normalize them, what we need to do is to use 2 to multiply the second equation. We use 2 to multiply the second equation. Here we'll turn 100 and then complement with 100 in the first equation. So we will do that right away. We are multiplying the second equation with just 2. I hope this can be visible. So 2 times 80 is going to be 160. All right? 2 times this is going to be 100. Current 1 plus 2 times 130 is going to be 260. 260 current 2. All right? We have succeeded in doing this, right? Very good. So what do we do next? We now apply the elimination method. The elimination method is taking this form, is minus sign. Okay, it's going to be minus sign. All right, minus sign. That's the elimination method. So what do we do at this point? We now say we call this equation number 3 because it's a new equation entirely, generated from multiply the second equation with number 2. All right, that should be clear. Okay, at this point, if there is anything that is not clear, feel free to drop it in the comment section. So let's quickly move on. 20 minus 160 is going to give 140, all equal to, of course you can see we have 100 current 1, 100 current 1 again. So 100 minus 100 is going to give just 0 at this point. This minus, okay, is going to affect what we have here. It's going to turn this into minus. So it's going to be minus 80 minus, because this minus will affect this, minus 260. And we have minus 300 and then 40. Good. Remember we have I2, current 2. That's the one we are looking for. So quickly, it implies that current 2 is equal to minus 140 all over minus 340. Okay? Very clear. With this, it is clear now. Therefore, current 2 is equal to 0.412 amps. This is the answer. By the time we cancel out and then do the normal simplification using addition as division, we arrive at this. So we have successfully found the value of current 2, right? Let's quickly find the value of current 1 because it was initially eliminated. We eliminated current 1 at this point. So for us to find the value of current 1, we need to use the first equation. All right? We need to use the first equation. That's what it means. All right. Once again, I want to thank you midway for watching up to this moment. Don't forget to subscribe. All right? Give us some thumbs up. Share with your friends, students, and networks. Remember to put on the bell button for constant notification. Let's move into it immediately. So, solving for current 1, we are going to use the first equation, which is 20 is equal to 100 I1 minus 80 I2. All right? Very good. So we have 20 already given is equal to current 100 I1 minus 80. The value of current I2 is given as 0.412 amps. So we are going to substitute for I2 here, which is 0.412. Okay? And then we make current 1 the subject. It becomes current 1 is equal to 20. This comes over this side, becomes plus. All right? And then we have the 80 bracket 0.412 bracket close. Remember, we are going to divide all through and we have 100. Okay? That is it. Simple manipulation using basic arithmetical operators. Therefore, if we simplify this further, our I1 is going to be 0.53 amps. All right? Good. Now we have found the value of I1. We can now find the current I3 flowing. Current I3 flowing into this junction because it's the combination of current 1 and current 2 that join here and flow into resistor 3. So we do that by I1 is plus I2. That will give us I1 is 0.53, I2 is 0.412. So adding them together, you know what it means? Adding them together is going to give us something important. 0 here, right? 5 and 4 will give us 9. And then 3 and 1 will give us 4. And finally we bring down 2 amps, right? Alright, so that is the value of current 3. Thank you so much for watching up to this moment. Remember to subscribe, give us some thumbs up, share with your friends, students, and network. Don't forget to put on the bell button for constant notification so that each time contents like these are uploaded, you'll be notified immediately. Alright, thank you so much. Don't forget, I'll be linking other videos concerning applications of Kirchhoff's law 2, 3, 4, and so on and so forth. My basic explanation in terms of Kirchhoff's law in my previous 2 videos will also be linked, so feel free to watch those videos and get a learning advantage. Thank you so much.